Hello, this is a presentation which is presented at Diagrams 2022, and this is about why scholars are diagramming neural network models. So first of all, the current context. So in scholarly publications, so primarily this is conference venues, what we're seeing is that in other related work, we're seeing that almost all papers are including a system diagram, and that these diagrams are really important. So they're important partially because of their prevalence, but also because their citation counts associated with the papers, which is one of the key metrics for scholars, that is associated with diagram usage. So we've found that if they have a higher number of diagrams contained within a paper, then that is more likely to have a lower citation count. And if it includes a system diagram, then it's more likely to be highly cited. And it's more likely to be highly cited if it's compliant with more than 10 out of 12 of the guidelines in the framework. And finally, and the thing that we'll be focusing on in this paper is about that these diagrams are really heterogeneous, and we're going to talk a little bit more about exactly what we mean by that. And we think that we can gain some insights from that. So the heterogeneity relates to the content which is included in the diagrams, but also to the way that content is visually encoded. Further, it's things like it's semiotics, so things like whether the diagram is of a system or of a processing of data or of a human process, which is then being augmented by a system in some way. So there's different ways that things are signified. Sometimes mathematics is signified even. Another thing, a couple of things which came out of an interview study, which is reported separately, are around the tools used to create diagrams. So there's a huge variety of different tools that scholars are using to create these diagrams, and a huge variety of different ways in which readers are consuming those diagrams. So whether they're using it as an index to text, whether they're using it as a summary of the paper, or skim reading it, flicking straight to the diagram, using it in order to extract examples. There's a huge plethora of things, and it's perhaps easiest to see what I'm talking about in some examples. So we've got 3 examples coming up here. So this is one example. I'm going to flick through this fairly quickly in the interest of time. The second example, this one flows from bottom to top as previous, and it has mathematical notation overlaid. This example has more about a specific instantiation. So you see teddy bear sold, and you've got really visual representations of mathematical concepts. So there's even like multiplication and things like this being done kind of visually, which is interesting. And then in the bottom left of this, we've got by LSTM, which is a fairly iconic representation, but it's got the ellipsis in there as well. So it's not particularly efficient in terms of ink. But anyway, so we've got lots of different things happening in each of those examples. So why are these diagrams also different? So I think the first fundamental thing to understand is that they aren't hugely different systems. So they're describing the same kind of thing in that it's a neural network system. But that isn't to say that it's not complex. So a part of the explanation is probably about the high domain complexity. So there's quite a lot going on. There's different ways of there's different ways that people are creating diagrams. So there's different tools that people are using, which is then making certain visual encodings more natural or more straightforward. There are also different ways of conceptualizing the system. So whether the creator of the diagram is thinking about it in terms of the contribution they're making, or in terms of similar components. They might want to use things that they've seen in other people's diagrams, whether they're thinking about it in terms of a linear mathematical algorithm, or whether they're thinking about it as being some sort of multi-dimensional space. These different ways of conceptualizing is what we're talking about in this paper, and that I think so our hypothesis is that through that heterogeneity that we have, we are actually seeing we're getting some insight into the way that authors are conceiving of their systems and conceptualizing them. So in terms of readership, different mental operations certainly relate to these diagrams, and that also might apply to authorship as well. So in terms of apprehension, like how does this work? Judgment is, this is relevant to me, So this paper is relevant because it has a diagram that looks relevant or similar to something that I'm wanting to learn about. And inference, so this architecture, the way of building the system could be adapted by adding an extra module in here, etc. So there's a lot of there's a lot of reasoning happening during the usage of these diagrams. And I think, so it's the contribution of our paper really is about linking up this heterogeneity with the mental models and how people are conceiving of these systems. So diagrams used in scholarly communication obviously have a communicative intent, so they are trying to communicate a contribution and an approach and to explain. And as I've described, they've also got this mediating role. So the author is conceptualizing their system, they are expressing that in a diagrammatic form, and then the readers of that diagram are kind of loading in that conceptualization that author is expressing. So it's mediating a way of articulating that system. But there are also other social aspects. So a good paper should include a diagram. This kind of stuff. Even visual aesthetics. Having a like clean diagram might have a role in a peer review process, or even if something looks really complicated, it might be obfuscating the simplicity of it. So there's other social aspects that are fairly complex or not complicated. So yeah, so there's quite a lot going on, which makes it quite hard to unpick. However, there are bits of this that we can unpick. So a computer system, because it is expressing a computer system, it can be thought of in different ways that are related to the computer system rather than the diagram, if that makes sense. So the function, so what actually is happening, what operations are occurring, what are the different parts of the model, the data, so how is the data changing, mathematics, so how would we express those computer operations in a mathematical way, and code, which is actually the code objects which are being used and the order in which they are being called. So those exist separately from the diagram, but they are part of that conceptualization that's happening. So the context related things are more on the side of whether they include an example in that diagram, whether the focus of the diagram is about the scientific novelty or the contribution, and other parts of it that are less relevant to that contribution are omitted or given much less attention. And in another way that sometimes is used as an index to text, so they might put in a little label and say this is about section 1, and then it refers to a part of the text which gives a bit more detail. Another thing that happens sometimes is that they are references to other diagrams, so that they might have sub-figures, or they might have distinct diagrams with more detail in different levels. So thinking about this all the way through, on the left we have the kind of like input data to the system, the technical formalisms of the system, the mathematical formalisms of the system, and all the way on the right we have this system understanding, which is the thing trying to be articulated. And in between that, we have the actual AI system itself, and then mental model, and then how they're encoding that in the diagram, how the author is encoding that in the diagram. And we've linked together in the extended version of this paper about how that diagram expression relates to mental model theories in this fashion. So I think it's probably easiest to see this through examples. So going back to these examples, so this is about the contribution. So the scale dot product retention, that big blue block in the middle, is the main thing about the paper, and all of the other stuff is omitted. So the output, the inputs, to some degree, they're omitted. It's fairly schematic, but it's really saying, look, this is what we're doing. We're bringing together these 3 different pointwise linear operations, and we're doing that scale dot product retention. So that's about contribution. And the second example is much more about functions. So we've got lots of curvy arrows. We've got some mathematical overlays there as well, but you can see the dynamic nature of the way that the creator is trying to articulate the system. There's processing from left to right and right to left, and it's more like a kind of conveyor belt almost. And in the third example, there's much more about the data itself. So we've got tables and numbers and letters and graphs in the sense of nodes with connecting lines. And so that perhaps is, this one's quite complicated. It includes quite a lot of different concepts, but the idea here being that the focus is on the data manipulation. And a final bonus example, so that we get some schematic ones as well. We haven't seen this example before because it's a bit lightweight, shall we say. So here, this one is doing a bit of a comparison between two different approaches, and it's just boxes with arrows and text. So that's very, very schematic, and it's about the sort of the form more than the function. So it's the components together. So in conclusion, the heterogeneity of these scholarly neural network diagrams may provide insight into the minds of their creators, and we hope that that is seen as being something that's interesting by others in the diagramming community. And just to reiterate that tooling is a potentially really high impact area for diagrams in this space. So if diagram researchers wanted to create tools to support different cognitive activities for this particular application area, that could be a huge impact because of the growth of AI and the importance of AI in the way, and the importance of diagrams in understanding AI. So if you're interested in any of those kind of topics, please send me an email, guy.marshall@manchester.ac.uk, and because we're writing some proposals for AI conferences to try to get diagrams a bit more front of mind there as well. Thank you very much for your attention.